Okay, let's start to begin as a square function and sort of, you should recall these things. If you're struggling with this, move on to a different question, but I'm not struggling with it yet. So let's write this down. So I'm going to say, let's see, the cosine of 2 theta is equal to 1 minus 2 sine squared theta. And that means we're going to get, let's see, we'll solve that for sine squared, right? And that's going to be 1 minus cosine 2 theta over 2. I think I'm ready. And let's write this over here. And again, we're taking a square power, right, as a linear factor now. So it's going to be 0 to pi over 2. And the sine squared is going to be what? 1 minus the cosine of twice the angle. So it's going to be 4x now. dx over 2. I'll put that on the outside. I think I can do this, 1/2, and the antiderivative of 1 is x. Antiderivative of cosine is sine, 4x over 4. Limits of integration are 0 to pi over 2. We're going to evaluate this now. You're going to get 1/2 pi over 2, that's what x is, minus, well, it's going to be the sine, well, 4 times pi over 2 is going to be 2 pi, and that means sine of 2 pi is 0. So that's pretty simple. Minus 1/2. The lower limit evaluates to 0. All right, that's pretty simple. What do you get over here? Pi over 4. All right. Now, by the way, when I'm taking an exam, I'd be looking through things, and I notice right here, I might get a little nervous with the Simpsons rule because I know it's a little bit tedious. But I do notice that what they give me is they give me the formula. I'll come back to that. This one over here, it's arc length. You should know how to do that, of course, but you might say it's getting a little tedious over there. And let's see if there's something easier to do. And yeah, this one doesn't look bad because they tell me what to do. And it's an integration problem. So let's write this down. So I'm going to write down, first of all, I'd like to write down what x squared is because I see that in the problem. And that's going to be what? 9 sine squared theta. I'd also like to write what dx is. And dx would be 3 cosine theta d theta. All right? I'd also like to write down, what 9 minus x squared is. That's 9 sine squared theta. I can factor the 9 out. The root of 9 is 3. And 1 minus sine squared, well, that's going to be cosine squared, right? And that's going to be in that, it's going to be, this invertible region anyway is going to be a cosine. So 3 cosine theta. The other thing I want to do is I want to do the limits. And if x is 3 over 2, that means you get 3 sine theta. I know the theta for that. Divide both sides by 3, you get 1/2. You get sine theta. Well, that's relatively simple. What do I know about that? The angle is going to be 30 degrees. I shouldn't be using degrees, though. And that would be pi over 6. All right, I'll write that down for you now. So I got some things to write down, pi over 6. I got to do the 0 still. And that 0 equals 3 sine theta. Well, theta's got to be 0 there. Theta 0. Let's write this down. So x squared dx, let's see, that's 9 sine squared. That's the x squared. I got that covered. The dx is this over here. Let's write that down. That's 3, whoops. That's 3 cosine theta, d theta. I got that covered, all right? Let me go backwards on that. And I want to see if I can do the bottom. Did I do the bottom? Yeah, I did. What is it? It's just 3 cosine theta. Let's write that down, 3 cosine theta. What happens here? These cancel off, and you get a very simple integral. What do you get? You get 9, and then you get 0, pi over 6, and you get sine squared. Well, this is deja vu all over again, right? Let's write this down. I'm pretty clear about that. And that's going to be 9. You can get 0, pi over 6. And we just did it, so I'm going to pull it out pretty quickly. So 1 minus the cosine of 2 theta, d theta. Don't panic yet. And we're going to have to do that now. That's going to be 9/2. You're going to get theta minus sine of 2 theta over 2 limits of integration are going to go from 0 to pi over 6. All right, let's put that down, and you're going to get 9 over 2, and then you're going to get pi over 6. Let me keep thinking through this one over here. So minus, there's going to be a 2 on the bottom, and then you're going to get sine of pi over 3. Now the lower limit, minus 9 over 2, that's going to be 0. All right, that makes it a lot easier for me to deal with it. But I still have to evaluate. All right, so let's go through that. So what are you going to get? And be careful about it. 9 over 2, it's going to be pi over 6, minus the sine of pi over 3. That's going to be root 3 over 2. So I get root 3 over 4. I'm going to do some arithmetic over here for you. 9 over 2. I'm going to say 12. And you get 2 pi minus 3 root 3s. I'm going to do some reductions. 3 goes into 12 4 times, and 3 goes into 9 3 times. So what do you get over here? 6 pi minus 9 root 3. And 2 times 4 is 8. I'll put a box in that. And, I'll go back to the other problems, but I want to keep scrolling through this and see what the next one's going to be. Next one doesn't look bad. And before I do that, the limit down, I like to do the indefinite integral first. And let me write that down for you. I think it's pretty easy to do. I'm going to make a u substitution. du would be minus dx. So I get minus, put a star here to remind myself, du, and this would be u to the 3 halves, minus u to the minus 3 halves, du, let's see, minus u, I'm going to increase the exponent by 1, so minus 1 half. I'm going to divide by minus 1 half, which is like dividing, by multiplying by minus 2, so say plus 2. And again, there's a constant integration on that as well. I'm going to write a little bit neater. I'm going to write it as 2 over the root of u. All right, so I think I did okay there. So let's write this down, limit. And by the way, u is 3 minus x. Let's write this down. So it's 2. This is plus some constant of integration here. Put star there. So the root of 3 minus x. All right, I'm ready to write this down. Limit as r goes to 3 from the left side. 1 to r. Oh, I can do the integration now. I'm not going to do that, right? So what do you have there? Got the antiderivative. It's 2, and it's going to be root 3 minus x, limit integration 1 to r. Let's go to town. Let's write this down. Limit as r goes to 3 from the left. Got to evaluate at r, so 2 over root 3, whoops, minus r, and then it's minus the lower limit, which is 2, and 3 minus 1 is root 2. It's not so bad. This is divergent, and the reason being is this limit goes off to infinity, so it's divergent. Put a box in that, we got the work. Let's see if there's another question there. Yeah, there is, just over here. Partial fractions, feel comfortable with that. Let me go to the partial fraction problem, and certainly when I do that, certainly your mileage may vary in this, but it doesn't look like a difficult problem. 13x squared plus 17x plus 2, denominator. I'm just doing the partial fractions, the MEM 119 material first. And I'm going to say a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared. Multiply both sides by the LCD. And you get a, x plus 1 squared, plus b, x plus 1, x minus 1, plus c, x minus 1. Well, the first number we're going to pick is actually x equals 1. All right, let's go for that. And that would give me 13 and 17, so I get 32. And what do you get there? You get 4a. And the term involving b's and c's disappear. So now I know what a is. A is 8. All right? So I'm going to get my eraser out, and I'm going to erase this over here. I'm going to put the number 8 down now. All right? I'm going to put the 8 where the other a is too. Let me get my eraser out again, make it smaller. okay? Let's take x equals minus 1 now. What do you get there? We get 13 minus 17, which is minus 4, and minus 4 plus 2 is minus 2. Now the terms that disappear are the first term and second term, but the third term would be minus 2c. So now I know c is going to be the number 1. That's convenient. Let's do that now. I'll erase this c over here and this c over here and just say it's 1. Let me see if I can get the b. And I'm going to do that is pick another simple number. I'll pick 0 this time. And what do you get? 2. Well, you're going to, if I pick 0, I'd get, let's see, 1 times 8, which is 8. And then you're going to get, if I pick 0 minus b, let's make sure if that's true, 0, yeah, minus 1. And then you get minus 1. There's a little more difficult. So it's going to be 2 equals 7 minus b, or b would be equal to 5. Let me get my eraser out, and I'll erase this over here, and I'll put the 5 down. All right, I think I got everything, and I think I'm ready to integrate. Now, I'm not going to rewrite the problem, by the way. I'm going to start to integrate. So someone says, what are you integrating? I'm going to do this first. I think I can do it. And what's that going to be? 8, the natural log, absolute value, x minus 1. I'm going to do this guy now. I think it looks fairly easy to do. And what do you get over there? Plus 5, natural log, absolute value, x plus 1. I got to do the last guy. To be honest with you, looking at it, I don't want to guess at it or think I can remember. I want to do something. I want to do side work. I'm going to put this over here. And I'm going to say u is equal to x plus 1. And du would be equal to dx. Well, that's convenient, isn't it? Nice and easy. Star. This would be u to the minus 2 du. And I can integrate that certainly quite easily. It's going to be u to the minus 1 divided by minus 1 plus c. So what do you have there? Minus 1 over u plus c. Again, I'm just doing some side work over here. And what was the u? The u was x plus 1, right? So I think I can do that now. And let's write that down. So what do you get? Minus 1 over x plus 1 plus c. I'll put a box on it. Let's see if there's something past 12. No, so I got to go back to the other ones now. And someone says, what are the ones you're going to do? I got to do the other ones, and I think I did okay. Some mistakes can happen. You know what? Let's try this one. I'm holding off on that other one. And what do they want to do? They want to do the length of arc between 1 and 2. So the first thing I would do is just simplify the equation by taking the square root of both sides. Y is a positive number, by the way. So you get 3y equals the root of x is x to the 1/2 times x minus 3. This is 3y equals x to the 3/2 minus 3x to the 1/2. I'm going to divide both sides by 3. You get y equals x to the 3/2 over 3 minus x to the 1/2. I'm going to differentiate it, dy dx. And you're going to get 3/2. Let's see, x, by the way, is over 3. I take away 1 from that, so 1/2. That's not so bad. And then minus 1/2, x to the minus 1/2. All right? So I'm going to clean it up a little bit, and I'm going to write it down a little bit differently. I'm going to write it as x to the 1/2 power. The 3's cancel, get 2. And this will be minus x to the minus 1/2 over 2. I'm going to keep rewriting it. And I'm noticing, well, let me write this down for you. I've got a common there of 2, x to the 1/2 minus x to the minus 1/2. Multiply top and bottom by x to the 1/2. And what do you get there? You get x minus 1 over 2 root x. And that's dy dx. All right, what I'm going to do now is I'm going to do 1 plus dy dx squared. What do you get there? 1 plus, this would be 4x. This would be x squared minus 2x plus 1. Well, 1 is 4x over 4x. So I get 4x here And then what do you get? You're going to get x squared plus 2x plus 1. Well, that's not so bad. And what do you get there? It's actually x plus 1 squared over 4x. And this is 1 plus dy dx squared. And you take its square root. I'll put that down for you. And this is going to be our integrand. So what do you get over here? You get x plus 1. And that's fine in that region, by the way. And then you're going to get 2 root x, which turns out to be, let's write this down carefully. It's going to be 1/2. And then x divided by root x is going to be root x. I'll write it as with a fractional exponent, by the way, because it's easier for me that way, because I have to integrate it. X to the 1/2 plus x to the minus 1/2. All right? So I think I'm close to being able to do the problem now. And I figured this out. And let's write this down now. So what do you get? You're going to get 0 to 2. We just computed the integrand, which turns out to be 1/2. I'll pull that on the outside. And this is going to be, I get my eraser out because this is the arc length. I'm going to call it L. And I pull the half out. We're going from 0 to 2. And it's going to be x to the 1/2 power. And then it's going to be plus x to the minus 1/2. And what do you get there? Let's write this down, 1/2. Let's see, I increase the exponent by 1, so that's 3 over 2. Divide by 3 over 2 is like multiply by 2/3. And then it's going to be plus, increase it by 1, so that's going to be 1/2. Divide by half or multiply by 2. And then you get limit integration 0 to 2. I got to do that. That's 1/2. And you still get 2/3 here. And x to 3/2 is going to be 2 root 2. Then you're going to get over here, 2 root 2. The 0 evaluates to 0, so it's 1/2 times 0. All right, let's keep going. And I'm going to factor out 2 root 2 from the top. So you get 2 root 2 over 2. I just factored these out from the top. What are you left off with? 2/3 plus 1, which is 3/3. And 2 root 2 over 2 is just root 2. And 2/3 plus 3/3 is 5/3. And what do you get there? 5 root 2s over 3. All right, so what I want to do is, again, I want to make sure I've answered all the questions. I didn't answer this one yet. And so I want to do this one now. I want to do it next. And certainly you're looking at these things, you're saying, I don't know if I can do that one. I think you can do it. And I want you to go back over it and put it down. But they gave me the formula. And I want to point it to the bottom of the page. All right? So, I need B, I need A, I need N, and I need F, and I need the C. So let's write these down one at a time. So the A is 2. Again, you can look at the bottom page for that. The B is 4. F of x, pretty simple, is 9 minus x squared, right? The N is 6. And I think that's what I need from it to do the formula. So let's go back over here. And the first thing I need is B minus A over 3n. Let's write that down. So B minus A, so this is going to be S6. So I need the B minus A over 3n. I need that. And what's B minus A? It's 4 minus 2, which is 2. And 3 times n is 18. And 2 divided by 18 is 1/9. And then I'm going to look back over here, right? So we got this part done. Let's put f of a down. What's f of a? Well, I'm not doing a computation. I said don't evaluate. I'm not going to evaluate it. That's just too much work. And then it's going to be plus. And I got a really nice pattern to it, right? So it's going to be, just point this out to you. 4, 2, 4, 2, 4, 2, 4, 2, 4, 2. Wow, it could go on forever, by the way. But the end of it will be f of a. We'll get there in a moment. Let me erase this over here. And I want to put the CIs down for you, all right? Let's write that down for you. And the CIs is going to equal, and this formula is given to you as well. It's right in the bottom. It's going to be the A. The A was 2 plus the B minus A. Well, the B minus A, 4 minus 2 is 2 over 6. And then it's going to be I. All right, let me show you where that is. It's right over here. This was given to me. Right, I want to simplify it though, because I have to do a bunch of calculations. So 2 plus, that'll be 1/3, right? And when you get there, it's actually going to be 6/3 plus 1/3 of an I. So I can start writing down my CIs down. For example, the C1 is going to be 7/3. The C2, let's see, 7/8. I would keep it in thirds, by the way. It makes it easier. That would be 9/3. C4 would be 10/3. And C5 would be 11/3. Now, a lot of students don't know when to stop. You can always extend it if you want, but I'm stopping at C5 for a reason, by the way. But you can certainly add on if you want. So what do we put down now? I'm going to start writing them down. It's going to be 4 times f of C1. What's C1? 7/3. Then it's going to be twice f of C2, which is 8/3, plus 4 f of, well, let's see, we did 7, 8, we're going 9/3, right? Plus 2 times f of, well, 10/3. Pretty easy to count this. Then you're going to get 4 f of 11/3. Well, if you count that, where would you be at? Be at 12/3. And what's 12/3? It's our stopping number, which is 4. And let's write this down. So it's going to be f of 4. All right, put a little box in this indicating this is the answer to this question over here. And again, no, we're not evaluating that. We're just writing down what the computation is. Thank you. Let me just scroll over, make sure I've answered all the questions though. So we did this one, got a box, we did this one, I did that one, I did that one, I did that one, we did this one. Yeah, they're all done. Thank you.